Direct proportion. Now, in our previous video, we have seen what is proportion. Proportion is nothing but equality of two ratios. So, today we will see what is direct proportion. But before that, let us see how does variation in one quantity brings in variation in another quantity. So, let us consider some examples. Okay, let us say that if the number of books purchased increases, then the cost also increases, correct? Or maybe if the speed of the car increases, then the distance covered by the car in a given time also increases. Or maybe a scenario can be in which for a given work, if the amount of work to be done is fixed, so for a given work, if there are more people, then we take less time to finish the work. So for a given work, if the number of workers increases, then the time taken to finish the work decreases. Now let us see all this scenario one by one. Okay, so the first one, when the number of books purchased increases, the cost also increases. So what are the two quantities here? Number of books is quantity 1 and cost is quantity 2. And what are we telling? That when the number of books are increasing, the cost to buy the books also increases. In the second scenario, the speed of the car is quantity 1 and the distance covered is your quantity 2. What is happening? Suppose if your car is going at a speed of say 10 kilometers per hour, then in 1 hour the car covers a distance of 10 kilometers. And if a car is going at a speed of 20 kilometers per hour, then in 1 hour, in the same time as before, the distance covered by the car will increase to 20. So when the speed is increasing, the distance covered is also increasing in a given time. And in the third scenario, we see that for a fixed amount of work, if the number of workers are increasing, if there are more workers, then the time taken to finish the work is less. Okay, so if the workers are increasing, then the time taken decreases. So the above two cases in which when one quantity is increasing, the other is also increasing, and when these two cases are example of direct proportion. We say that such two quantities are in direct proportion. When one is increasing, the other is also increasing. When one decreases, the other also decreases. The two quantities are varying in the same direction. That is called the direct proportion. And this particular case in which one quantity is increasing and the other is decreasing, the changes happening in opposite directions are called as inverse proportion. We will be seeing inverse proportion in our next video. In today's video, we will understand in detail what direct proportion is by taking the example. Okay, so let us take an example. Say cost of one book is 5 rupees, for example. So how much will be cost of 3 books? Rupees 15. 5 into 3. Unitary method. Cost of say 10 books will be 10. 5 into 10, which will be rupees 50, or maybe cost of 100 such books will be 5 into 100, rupees 500. What do we see here? That the two quantities are the number of books and the cost of those many books. And what do we see? When the cost is increasing from 1 to 10, 1 to 3 to 10 to 100, when the number of books are increasing, the cost is also going up from 5 to 500. When the number of books are going from 1 to 100, the cost is also going up from rupees 5 to rupees 500. Both the quantities, one is increasing, the other is also increasing, and such proportion is called a direct proportion. Now let us form a table with these values. Okay. The first row represents the number of books and the second represents the cost. So when the one book is there, the cost is rupees 5. When 2 books, cost is 10. When 3 books, the cost is 15. When 4 books, the cost is 20. 5 books, the cost is 25, and so on. What do we observe in this table? We see that look at the values of the number of books and the cost. Do you observe anything from the table? What do we see here? We see that the ratio of these two, the ratio of these two, the ratio of these two, and the ratio of these two are all same. So if we try to find out the ratio of number of books bought to its corresponding cost, what do we get? Ratio is nothing but a fraction. So for the first case, we are getting 1 by 5. For the second case, it is 2 over 10. When we reduce this fraction to its lowest form, cancel out the common factor 2, we again get 1 over 5. For the third, it is 3 over 15. Cancel out the common factor 3 to get a ratio 1 by 5 again. In the fourth case, it is 4 over 20. Cancel out the common factor 4 to get a 1 by 5 again. So we see that the ratio of particular number of books and its associated cost always remain constant, and it is a constant 1 by 5. So if X is the number of books bought and Y is the cost of those many books, then we see that X upon Y is always a constant K. Okay, and such proportion is called a direct proportion. So what do we see here? We see that if Y1 and Y2 are the costs of X1 and X2 books respectively, then the ratio of the number of books to its corresponding cost is a constant K, and the ratio of number of books to its corresponding cost is again a constant. So from here we see that x1 upon y1 and x2 upon y2, they both are equal to a constant. So they both are equal. x1 upon y1 is equal to x2 upon y2. And these are called the equivalent ratios. Correct? And this statement of equality of ratios is called a proportion. Correct? Proportion is nothing but equality of two ratios. So this can be written as x1 is to y1 is in proportion to x2 is to y2, which can be written as x1 upon y1 is equal to x2 upon y2, or x1 upon x2 is equal to y1 upon y2. Okay, so this is the relation which holds good when R proportion is a direct proportion. Whenever there are two quantities such that when one quantity changes, increases, the other quantity also increases, that proportion is a direct proportion, and the relation is given by x1 upon x2 is equal to y1 upon y2, where y1 and y2 are the values of one quantity corresponding to the x1 and x2 values of the previous quantities. Okay, so here if we look in this table, all these values of x are nothing but the instances of x as x1, x2, x3, x4 and so on, and the corresponding instances of the cost, which is y, is y1, y2, y3, y4 and so on. So we see that x1 upon x2 is equal to y1 upon y2 in case of a direct proportion. Also, the direct proportion is represented as, if there are two quantities x and y and they are in direct proportion, then we represent direct proportion by this symbol. We say that x is directly proportional to y. I hope this much is clear to everyone. Okay, now let us consider an example. Suppose the two quantities that are given to you is, say, the petrol that is used by car in liters, and it is already given that it is directly proportional to the distance covered by the car in kilometers. Okay, one table is given. Petrol in liters and distance in kilometers. Okay, we say that in 4 liters of petrol, okay, maybe the car is traveling say 60 kilometers. So how much will the car travel in 8 liters of petrol? We have to find out. Okay, since it's given to us that it is a direct proportion, we know that in direct proportion this ratio is constant. And this, if petrol is your quantity x and distance is your quantity y, then these are the instances of the quantity x as x1 and x2, and the corresponding instances of distance covered is y1 and y2. So x1 upon y1 is a constant and it should be same as x2 upon y2. Both of them are equal to some constant k. We will use this equality, this much. So x1 is 4 over 60 is equal to 8 over y2. Let us cross multiply. So we get 4 into y2 is equal to 8 into 60. So from here y2 comes as 8 into 60 over 4. Cancel out the common factors and we get y2 as 120 kilometers. Okay, so we say that when a car can run a distance of 60 kilometers in 4 liters of petrol and 120 kilometers in 8 liters of petrol, and the petrol and the distance are in direct proportion. Okay, so this is all about direct proportion. Direct proportion, the two quantities are in direct proportion when one quantity increases and the other quantity also increases. The other quantity which is related to this first quantity also increases. If one quantity is decreasing, the other quantity is also decreasing. So the change in both the quantities are in the same direction. Okay, one is increasing, the other is increasing, one is decreasing, the other is decreasing.